Hello everyone. Today we are going to solve this sliding window maximum problem. Let me first see my live stream working or not. We are going to solve this sliding window first. So now our audio is working correctly. We check the live stream. So what we have to do in this problem, we will be given an array, and inside that array we will also be given a window. Let's say the window of 3. So in this array, what you have to do, you have to find the maximum number between that given window. So from here, let's say we start, then our maximum window is 1 3, and our window is 1 3 and minus 1. So what is the maximum one? It's 3. Now our next window will be 3 minus 1 and 3. So which one is the maximum? 3 is the maximum. Now this will be our next window, this will be next, and until up to here we have to find the maximum of each window and then return in the format of the array. If you want to have the better understanding, you can see this is our first index, maximum is 3, output is 3. This is second maximum, and we have output also 3, and this is the third, fourth, fifth, and this is the last window in which we have 7 as the maximum. And if you see, look at the constant, the array length can go up to the 10 to the power 5, which is around 10,000, 100,000 round. And also the number of the array can go up to minus 10 to the power 4 to plus 10 to the power 4. And k will always be a positive number. It will be either be 1 or uh, inst will also less than the number of the array length. So now I have already implemented a ON solution, ON by M solution. I don't know if it's ON square or, but it's probably ON M because we are looking through the each window every time. So this is going to remain the constant depending on the k. So we can say N by M, the time complexity. So if we look at the naive way, that brute force, what we do, we take an output, we loop through each of the item. Then what we do, we create windows. So here we are taking, let's say we are at index number 0. Then we create a window of 3. So this will be our window. Then we're taking the maximum item and pushing into our array. Now our I will be here. So we create next window, and then we iterate through this window from again and select the maximum one. And same we do this for next all of the items. This is giving the correct solution, but the problem is it's getting time out. So you can see time limit exceed. I have already solved it in ON time with the Deque, but let's do it again. So in our Deque approach, what we are going to do, we are going to use a double-ended cube. So we will enter the we will loop through the array only once. Then what we are going to do, we are going to put the top the greater element always at the front of the that queue. So greater the element which is greater than the previous element is always going to be top. Then we are going to take it and push it to our array. So let me do that quickly. First we create our queue which is an empty array. A JavaScript don't have any inbuilt library or which we can use the queue data structure. So what we are going to use the array. So for removing from front we will do array.shift. Removing from back we will do array.pop. Or if we want to insert at the back, then we do array.push. So in our case we will remove from the front and back, both of those, and also push from only back. So our top element is going to be at the topmost always. Now we don't have to check for the null or empty conditions because our array is always going to be either 1 or also our k is going to be 1. So first what we have to do, we have to initialize a queue with the starting window maximum. So let's say we will calculate this first maximum to initialize our queue. Then after that we can run through our algorithm. So what we have to do, we have to run let 0 and I less than the size of window size. Then we can do I plus plus. And one more thing is that we are not going to push our elements. We are going to push only the index number of the element. Why we are doing this? Because we will have to check if the current items are only the items which is present in the window, our current window. So if any item is outside our window, we don't want it in our queue. We will just remove it, and only the current window item is going to remain in the queue. And let me check. So what we are going to do, our condition will be that our queue should not be the empty. So queue dot length, but we are going to do it for the looping through we have to loop through the queue. So we have to use this while queue dot length is greater than 0. So there is always should be one item in the queue, and the current array item, if it's greater than the size of the queue, the first element of the queue. So it will be array. Yeah, we have to fetch the item from array because we are not going to push into the queue. So it will be queue, and we have to fetch the last item of the queue. So queue dot length -1. Now let's say we already have one item in the queue which was greater than. So in this case we push 1 in the queue. Now we come at the second position, which is 3. So let me just do that. So let's say this condition goes false for the first item. So what we are going to do, we are going to do queue dot push I. So we are going to push the index. So this item now is in the queue. So when second time our loop is going to execute, this condition will become true, and our array item 3 is greater than the 1. So what we are going to do, queue dot pop. So we are removing the element which is not the greater than from the top. So now this 3 is greater than, what we are going to do, we are going to do q dot push. So this will be our greater element at top. Now once our for loop is end, we will have the top element, in this case 3, in our queue. So we can do a, also have to take a result array. So I can do result push, and it will be q, not the q array, and the index of the array, which will be the q 0th index. So we will fetch the first item. In this case, let's say our queue has 3, only 3, so we will put 3 for the result, because in first sliding window, for first window, we have calculated our maximum, which is 3. So now at the end of the loop, we are putting 3 inside. Now the same algorithm goes again, but this time for the rest of the array. First we have calculated for one window to initialize our Deque to do the operation. Now we are going to do for the whole rest of the array. So the loop is going to run the same. Let me return the result, but before that I will be equal to the window size. And why it's going to be window size? Because I is already here and we want to start from here. So let's say window size was 3, so we have already calculated for 3. So 0, 1, 2, these 3 items. Now we are going to add the 3. So window is 3 in this case, so 0, 1, 2 and 3. Our index from will start from here, and it will be less than the array. So I should be less than, otherwise deleting. Where is insert? Control insert. Now come array dot length. Now we can do I plus plus, and now we are going to check same. Only top element should be at the top of the queue. Now we have to check for another condition also, and that will be that our the current in window, let's say it was our previous window, and 3 is or any item which is remaining in the window. So now our window is this, and maybe let's suppose in some cases this one will be there. So 3 is greater than, and it's not going to, this condition is not going to delete the 1 if we have 1 inside the index, and this is outside our current index, because our current index is this and the 1 is outside the window. So what we have to check, if any of the item is outside the window, then delete them. So q dot length should be greater than 0, and q 0th item index. So let's say q0, if it's less than or equals to the ith index minus window size. So we will get this item. Let's say if our window is this, then we are going to get this one. Then we have to remove from the front. So at the top, greater than element will be there, but at the here we will have the previous element, which may be not the part of the our current window. So we will do q dot shift, so it will remove from the front. Now we pushing into the queue again, greater than a greater element or the element uh, which is currently we have to push in the queue. Now what we are going to do, we are going to do result dot push same array queue 0. What's wrong? It's function insert. So now algorithm is ready. First we initialize the queue with the starting window. Then we run for the rest of the item and check that the top element should be always at the top. I mean the greater than elements of the current window should be at the top always. And then we also check if the current queue is having the element outside the window. There should be no element outside the window in the R queue. If there is any element such element found, then we do queue.shift and remove. After that, we push the top element in the queue and push the result into the array. So let me run it quickly. Yeah, Q0. Okay. This is immutable because of the editor. I don't know how to result of push array, then result of push array Q0. Run again. Hope it works now. There are going to be lot of it. QUE. Then अरे यार क्या दिक्कत है इसकी. I cannot even format the code. Is there anything wrong on this thing? Key binding is standard. I will die solving this. Entering this editor. There is something seriously wrong. Let me reload it. Let's just go here. Code. Get lost. Okay, and it's working now. So let me check the quickly. I goes to 0. Now let's then side of the points greater than 0 and here current item is greater than this push result of push to this is correct. Size plus while q dot rank is greater than 0 and then q0 is less than or equal to the size. We will shift to push array there should be no error. There is We are missing one semicolon here. Okay, use example test cases. Come on. Now our example test cases are also working. So let's submit and hope this will be submitted. It's already accepted. Yeah, you can see faster than the 44% because the implementation of this array, we are using this array as a Deque, and the push, pop, and shift, these operations are expensive. In JavaScript, they may be taking longer than, I mean, more than the n times. So in, let's say if it's in Java, maybe they are having a push pop operation in one time over the constant time. But in JavaScript, it's depending on the size of the array. So it's maybe becoming the big O of n. So yeah, this was our algorithm, which is working fine. And I will put this code in the snippet so you will understand better. Let me add comment for initialize the queue with the starting windows elements. Through the remaining elements. Now greater elements to the queue, and this is going to be if an element is outside the window, remove it. I had very hard time finding this solution, but I find it somewhere on the internet. Yes, I think it was on YouTube. But now I also do understand, and I can also make people understand how this is working. So yeah, let me upload it on GitHub. I will create a list. Slide JS. Let me put some description on it. Create. Now I'm sharing this link in the live chat. Not live chat, in the description. You can copy from there. Let me source code. So yeah, this was it, and bye bye. I will see you soon, guys, again in the next video. Till then, bye.